Hello and welcome to this video on ionic bonding. Now before we start looking at bonding itself, let's think about the periodic table. We've covered this in a recent video. And what do we know? Well, the group is what we're interested in here. The group number tells you how many electrons there are in the outer shell. So in group 1 there's 1 electron in the outer shell, group 2 there's 2, 3 and so on. And this is what we're particularly interested in, group 8 over here. Now elements in group 8 all have 8 electrons in their outer shell. They are full. Now group 8, very interestingly, or group 0 you can see in some books, are known as the inert gases. And the reason we call them inert gases is because they don't react. Inert means do not react. And why don't they react? Well, they all have a full outer shell of electrons and so they are stable. Now, every other element in the periodic table has an incomplete outer shell, and they want to have a full outer shell because in doing so they become more stable. Now, elements can fill their outer energy levels or orbits in one of two ways. They can either gain or lose electrons, or alternatively they can share electrons. We have special names for both of these. If they gain or lose electrons, we call this ionic bonding. If they share electrons between atoms, this is called covalent bonding. Okay? For example of ionic bonding, let's look now at lithium. So here we're looking at ionic bonding. We'll cover covalent bonding in a later video. Here's lithium. This is what we know. Lithium, symbol Li, it's got a mass number of 7. It's got atomic number of 3. Now this is what we're interested in here, the 3. Okay, so lithium has an atomic number 3, so has 3 electrons. Now as you know, the first 2 electrons go in the first orbit or energy level. As we can see here, there's 1, 2 in the first orbit, and the remaining 1 electron goes in the second orbit. So it's got 3 electrons, you fill up the first one first, as one would. So we've got 2 there, the third electron goes to the next orbit here. Now electron configuration, as we call it, or arrangement, can also be written in this format, 2, 1. 2 means there's 2 electrons in the innermost orbit and 1 in the outermost. Now I sometimes use this because I'm rubbish at drawing circles. It's up to you though what you choose to use. So we know lithium has got 1 electron in the outer shell. To become stable, lithium needs to achieve a full outer shell. It can do this in one of 2 ways. So to become stable, lithium will either gain 7, 1, 2 and so on, or lose 1. Now what's easier? Pretty obviously it's much easier to lose 1 than to gain 7. So if lithium loses 1 electron, the charges around here now become unbalanced. Lithium will now have only 2 electrons, these 2 here, because this one's been given away, but the nucleus still has 3 protons. So the overall charge is -2 and +3. The overall charge must now be +1. Now a charged atom is known as an ion. Note the spelling of it, I-O-N. Lithium ion has a charge of +1 and is written as Li+. We don't tend to put the +1, we just put the plus there, okay? You'll see in a minute we use 2, sometimes all 3s. This is a key slide, okay? Memorize this one. All metals form positive ions. That is so important. So all metals form positive ions because they lose electrons, and they're also known, these ions, as cations, and non-metals form negative ions because they gain electrons, and negative ions known as anions. This is just so important. So go over it again. All metals form positive ions, non-metals form negative ions. It's so important to grasp that bit. Here are some examples of cations and anions. So sodium is Na+. Magnesium, now just get there, magnesium is in group 2. So magnesium needs to lose 2 electrons, and if it does so, it's got a charge of +2. Similarly, calcium is in group 2. That needs to lose 2 electrons. That also becomes +2. Potassium is in group 1, so it's plus. Okay, these are all metals. These are all positively charged metals. Over here we've got the negatively charged non-metals. Chlorine, Cl-. So I'll rephrase that should be chloride. Okay, when it becomes an ion, the name changes to chloride. Here's chloride minus. Oxide, minus 2. Oxygen's in group 6, it can gain 2 electrons, hence it gains 2 charges and becomes minus 2. Nitride is in group 5, gains 3 electrons, becomes minus 3. Fluoride is in group 7, gains 1 electron, become F minus. So notice all these: chloride, oxide, nitride and fluoride. These are non-metal ions, so they are negative. These are all metal ions, they are positive, and the charge is given by the number of electrons they've gained or lost. Let's look at an example of a positive ion or cation formation. Now, aluminium is found in group 3. It's got atomic number 13, which means it has 13 protons, and we know it has 13 electrons. The configuration, you now know this arrangement: 2 in the innermost orbit, 8, 3. Now, to become stable, aluminium needs to lose those 3 electrons there from its outermost shell. If it does that, it will now have 13 protons from here, which is 13 pluses, and because it's lost 3 electrons, now it has only 10. Now, if your maths is pretty good, you'll know that 13 pluses and 10 minuses means you've got an overall charge of 3 plus. So this is written as Al plus 3, and that is the aluminium ion. Let's look now at an example of a negative ion, an anion, and this happens to be oxygen. Now, oxygen is in group 6, so group 6 non-metal. It's got atomic number 8. Protons has got 8, we know that from this. Electrons also has got 8, we know from that as well. So configuration: 2 in the innermost shell, then 6 in the outermost shell. Now, to become stable, oxygen needs to gain 2 electrons, so it will now have 8. So it will now have 8 protons, 10 electrons, I said 8 in the outermost shell there. So overall charge is 8 pluses, 10 minuses is 2 minus. This is written as O2 minus or O minus 2 and becomes the oxide ion. Hope that makes sense. Just to make sure it makes sense, let's do a little brief summary, shall we? Ionic bonds form between metals and non-metals. Metal atoms lose electrons to form positive ions. Non-metal atoms gain electrons to form negative ions. And because you've got a positive and negative, the oppositely charged ions attract each other to form a very, very strong bond. And that is the ionic bond. Let's look at an example of ionic bond formation, and we'll take as our example sodium chloride. Now, sodium, Na, has got 1 electron in its outermost shell, therefore needs to lose electron to become stable. Chlorine is in group 7 and it's got 7 electrons in its outer shell. It needs to gain an electron to become stable. So what happens? Well, this electron here from sodium will be transferred from the outer shell to the outer shell of chlorine. So now you've got a full outer shell of sodium is now 2, 8, and the full outer shell of chlorine is now 2, 8, 8, as we can see here. Okay. Sodium now has 11 protons still there in the nucleus, 10 electrons because it's lost 1, overall charge is +1, Na+. Chlorine now has 17 protons there in the nucleus, 17 pluses, and 18 electrons because it's gained 1, so 17 pluses, 18 minuses, overall charge is -1. Pretty good. As a result, electron transfer between sodium and chlorine, 2 ions are formed, Na+ and Cl-. You know that opposites attract, and so an ionic compound is formed, sodium chloride. That's relatively simple, isn't it? Relatively. Now, here's another one. This is magnesium oxide. Now, magnesium is in group 2, so magnesium has got 2 electrons outer shell. It needs to lose those 2 to become stable. Oxygen is in group 6. It's got 6 electrons outer shell. It needs to gain 2 to become stable. So yeah, I think you can guess what's going to happen here. 2 electrons are transferred from magnesium, this one to the outer shell of oxygen, and this one from the outer shell of oxygen. So 2 electrons will be transferred to the outer shell of magnesium, leaving it as 2, 8, to the outer shell of oxygen, which also becomes 2, 8. In terms of charges, well, magnesium has still got 12 protons there, but now it's only got 10 electrons. So 12 pluses and 10 minuses, overall charge is +2, we've got Mg2+. Oxygen, okay, still got 8 pluses in the nucleus, but it's now got 10 electrons. So we've got 8 pluses, 10 minuses, overall charges -2. So as a result, electron transfer between magnesium and oxygen, the compound magnesium oxide is formed. This contains the ions Mg2+, O2-, and the attraction, pluses and minuses, between these ions forms a very, very strong ionic bond. Now, to summarize this whole video so far, only the group 8 or group 0 elements are stable with full outer shells or orbits. Okay, that's the group that only group 8 has a full outer shell. To become stable, all other elements need to lose or gain electrons from their outer shells. All metals, remember this, lose electrons, so become positively charged ions. All non-metals gain electrons, and so become negatively charged ions. And the positive and negative ions attract each other, and so form very, very strong ionic bonds. Now, you remember that summary, then that is really, really good. While we're looking at ionic bonding, let's just think for a moment about giant ionic structures. You may come across these. Ionic bonding can result in the formation of giant ionic structures. And look there, we've got the ions plus and minus. These are regular lattices, regular shaped, and they're called giant ionic lattices, held together by strong forces of attraction between opposite charged ions, between the positives and negatives. Positive, negative, all held tight together. Okay? This results in having high melting and boiling points. Another thing about these ionic structures, and also ionic compounds generally, they also conduct electricity when molten. That means when liquid or in solution, because the charged ions are free to move about. And there we have it. Okay, that's the end of this video. Hope you now understand about ionic bonding. Thanks for watching and listening, and I will be back with another video very soon. So bye bye for now.